This application is for a reality check on the aeration system based on loadings and flows for an activated sludge process. A lot of times you need a reality check when you want to find out how a plant is loaded. We'll start with the flow and organic loading for the air sizing. I have just inputted values of 225 for the applied BOD, 25 for the effluent, 1.25 for the million for the flow, 1.21,250,000 gallons a day. Ammonia coming in 35, going out 10, and an installed blower capacity of 1,375 SCFM. The NOx will be computed because if you take 35 minus 10, it says that there's 25 parts per million converted to nitrates. Mixing factor, in this particular case, I just used 15. Rule of thumb is normally from 20 to 30 cubic feet a minute per 1,000 cubic feet of aeration tank volume. You can put in the number of tanks, okay, and the type of tank. So in here we have a rectangular tank. We have one tank on line, and we have the dimensions of the tank. Side water depth 9.5, length 150, and 35 foot wide. And then the application then calculates out based on the flow, the hydraulic detention time, and the volumes. Okay. Obviously, it was a rectangular tank, so the round volume is not employed. Blower sizing, efficiency of the blower, inlet and outlet pressures, gas constant, specific heat ratio, air safety factor. This is 1.25, which is like a 25%. The other one is the diffuser airflow rate at depth. You use the manufacturer, but in this case we use 2.5 SCFM per diffuser. The output from the program gives you the data for the power requirements, airflow for mixing, aeration mixing controls. It says that for the organic carbon and nitrogen we need 475 SCFM. For mixing we need 748. The number of diffusers comes back based on the diffuser information at 374. There is the airflow required for mixing, and the total airflow with a safety factor is 935. We come down and we do pipes and fittings. We got an 8-inch diameter pipe, 350 feet, 7 elbows, 4 valves. System losses, we're operating at 6 psi, and the app calculates out what the losses will be. This is your tank volume, and this is the aeration time. This is an interactive graph, and you can see that the X's and O's and excuse me, it gives you the airflow at this loading, and it gives you the BOD load. So right now we're at like 225, and it says that this is where this dot is where it intersects the air for mixing. Inflow flow versus airflow. This also gives you an interpretation of the configuration that you have. We come down here, you have your fitting losses based on the coefficients for L's and valves. It gives you the equivalent feet of each. You can come down here, and the flow control valve is the same thing, and it says here like we got a 6.21 psi across the valve. Energy cost, you can put in your cost of electricity per kilowatt hour and efficiency and come up with the annual cost. Oxygen organic loading versus airflow, 25% efficiency, it's a decimal. You wind up with 3,000 pounds a day. Sludge wasting, you can put in your sludge wasting and it'll go through the rest of the calculations. Piping temperature rise, this was put in just in case you happen to have some form of PVC or plastic pipe. Not that you wouldn't want to know what the temperature rise is. Here it says PVC status is okay. The electricity cost is estimated here. You have oxygen transfer. You have sludge wasting, and that is an input value at 10,000 gallons a day. Air mixing, it gives you calculates out the density of the air. You put in your efficiency value. You can put in your blower if you have a rotary row blower. This will allow you to adjust the pulley size if you need more speed, more or less speed, depending on the blower specs. And then there's a power evaluation, installed aeration, and you'll see here that it's 1,375. Influent BOD, it plots at 225, and air for plotting is 425. I just put in mechanical mixing to see as a comparison for the volume of the tank. So what this is a reality scan up here. What this is a reality check on how your system is configured and what the loadings are doing. Okay, if you change any of these variables, it will impact all your calculations down as well. And again, this chart is interactive, so if I were to change 225, and let's make it 175, I'll make this the influent BOD 175, I'll blank it and go 175, and I'll solve. And then if I come down here and I look at the graph, it's solving, and I look at the graph, and you'll see now I'm at 175, and you'll see that we're much lower on here.